This is for year 11 methods. We're going to look at exercise 6A, question 4D, and question 8. So question 4D, we're given a polynomial. You notice there's two unknowns, and we're given two pieces of information to sub in to solve for the unknowns. Okay, so when x equals -1, y is 0, and when x equals 2, y is 0. Okay, so we can sub two points in and solve them simultaneously. So we'll sub in -1 first into p of x. Okay, so meaning when x is -1, y is 0. When y is 0, x is -1. Now -1 to the power 6 is just positive 1, so it's 3. -1 to the power 3 is -1. -1 times 5 is positive 5. -1 squared is it's positive 1, it's just a. And -1b or negative b plus 10. Okay, all you have to do is put the numbers on one side and then the letters on the other. So we'll leave the letters on the right hand side. 3 plus 5 is 8, 8 plus 10 is 18. So if I move the 18 to the other side, it'll be -18. That's your equation 1. Equation 2, we've got 3x to the power 6. So if I sub in 2 for x and 0 for y. All right, so I know 3 to 2 to the power 4 is 16, 2 to the power 5 is 32, 2 to the power 6 is 64. So we've got 64 multiplied by 3. So we need to work that out. 3 60s are 180, 180 plus 12. 180 plus 12 is 192. Okay, and then you've got 2 cubed. 2 cubed is 8. 8 5s are 40, so minus 40 plus 4a plus 2b plus 10. Okay, so move all the numbers to one side. So we need to figure out the numbers. 192 minus 40 is 152. 152 plus 10 is 162, so minus 162. And then we've got 4a plus 2b. Now I might make this easy for myself and divide this by 2 because I know that they're all going to 2. So that's 81 equals 2a plus b. Now why did I do that? Because if I move this equation over here, so I've got -81 equals 2a plus b, I can solve this simultaneously using the elimination method. If I add these two equations, I can get rid of the b's, so that goes away. I'm left with 3a equals to, okay, minus 18 minus 81, so it's like adding them together, you're getting more negative. I'll do 10, 81 minus 10 first, minus 10, that's minus 91, minus 91 minus 9 is 99, okay, that's nice. So A would equal 3 divided by 99 divided by 3, so that's minus 33. Now to work out B, you can substitute A back into either one equation, so I might want to sub back to equation 1. So when I sub back to equation 1, I get negative 18 equals negative 33 minus B. I add 33 to both sides. So I get 33, 12 plus 3, 15. So 15 equals minus B, B equals minus 15. Then I solve for A and B. So that's basically how you do question 4. Okay, question 5. You want to expand the second expression, the one with x minus b squared plus c. Okay, why are we doing that? Because we want to equate coefficients. Okay? Just comparing apples with apples. So x squared minus, remember you go that times that. So x times minus b is minus xb, double that, so minus 2xb plus b squared plus c. Okay, now you've got your x term, you've got your x squared term, you've got your x term, you got your constant. Okay, that's your constant because those two don't have x in it. Okay, so you're going to compare them. So for the x squares, you know 1 equals to 1 because the number in front of the x squared and number in front of the squares, 1 is equal to 1. Okay, great, doesn't do anything. X terms, you've got 6x equals minus, I'll rewrite this, it's bx, okay? The reason why I'm doing that because I'm reading the number in front of the x, it's minus 2b. And sorry, that shouldn't be an x. So the number in front of this x is a 6. The number in front of this x is a minus 2b. So you can solve for b. So divide both sides by -2, b equals -3. Okay, I've done, we'll solve for b. For c, we have to equate the constant terms, x power 0. So constant, we've got -2 here. On the right hand side, we've got b squared plus c. And we all know what b squared is. B is, so b is -3, so -3 squared is 9. So c would equal -12. So b equals -3, c equals -12. And that is, those are your answers. So this was an equating the coefficient type question. Okay, so I guess students get confused with the constant term. This is constant, but these two make up the constant because they don't have an x with it, okay? Hopefully that helps.